Did you get two? I will make that.
You ready? Number 41? Come on, guys. You should have your stuff out, ready to go. All right. So, the easiest way to do this, you ready? Is to take all of these and multiply them together. So, 0.6 times 0.2, 0.7 times 0.4, 0.8 times 0.3, 0.9 times 0.10, okay? So tell me what you get. You got your calculators? What's 0.6 times 0.2?
0.10 times 0.2.
0.6 times 0.2. 0.12 or 0.7 times 0.4? How much? 28? Okay. And next one? 24? Okay. And the last one? How much? 90? And add them all together and you get? Yeah, that one's not right. That's 0.09. I was like, I knew that didn't sound right. There we go. Add those all up. I got 0.73. Did y'all get that? Okay, now, how many rooms did the hotel offer? 80. So you take the 80 and times it by the 0.73, and that should give you your answer. I got 58.4. So, what answer is that? That's C. Y'all okay? Okay, so, we already, you know what, yesterday we reviewed 39 through 42, didn't we? We already did that? Okay. All right, well, let's do this. You ready? You got your homework?
Can you still go over number 10?
I am going to go over it. Yep. Okay.
Wait, I already did that. I thought you were going to
Yep. All right. Which ones do I need to go over? 6, somebody said? Okay. 9 and 10? 8? 7? 5?
10.
Got it?
Already got it.
Last call. All right, turn your homework in. Please make sure your name is on it.
Is it okay if I just cut it?
That's fine. Please make sure your name is on it and turn it in. If you did it on a separate sheet of paper, that's the only thing you need to turn in. You don't have to turn in both of them. I just need your work. All right, wait. Give you about 2 more minutes, and then we're going to get started. I got a couple people still turning in stuff. Y'all okay? Ready to go? All right, here we go. Number 5. Let's look at number 5. What would we do first?
Combine the two
The divide thing.
The divide thing. Very good. We're going to make these 2 logs into one single logarithm by dividing. Y'all okay?
Both sides are logs. You can multiply them 3.
Okay, now be careful. We had both sides were logs to begin with. Why is this different? How are these 2 different? Why can I not set these equal to begin with, but I can set these equal now?
Oh, because there's still a problem to the left side.
Yeah? So how many logs do we have on both sides?
2.
on each side.
You have to make sure there's only one.
You have to make sure there's only one on each side. How many did I have to start with up here?
30.
I had 3, 2 on one side and 1 on one side. Okay, that has to be 1 and 1. Do they have the same base? Yes, so now I can set those equal, okay? All right, do you notice how the x minus 1 had parentheses around it? That's a huge deal, okay? Make sure that you're careful about that, especially on number 7, because that's probably what threw y'all off on number 7. All right, so here we go. We would multiply by 3. When you do that, you have to use parentheses. So 2x is equal to 3x minus 3. Move the 3x by subtracting. That'd be negative 1. Divide, and you should have gotten positive 3. Y'all okay? Now, if you showed your work, you will get partial credit, okay? But you have to show me work so I can see what you did wrong. All right, what about number 6? What would we do first?
Distribute the 2.
No.
Wow.
Make it the exponent. Okay, so that'd be log base 4 of x plus 1 squared. Again, do you see how the x plus 1 has parentheses? That's a big deal. Okay, now that I have one log on both sides, what can we do?
Oh, Lord.
We just did it. You have one log on both sides. What can you do?
Now you,
Set them equal. Very good. You have to have one log on both sides. Now, what does this mean right here?
2x plus 2.
No. You have to write it twice. Come on, we've been doing this forever. You have to write it twice. Then we would FOIL it. That'd be x squared plus 1x plus 1x plus 1. That would be x squared plus 2x plus 1. Add the x, that would give you 3x. Subtract the 11, that would give you negative 10. What are the factors of 10 that add or subtract to be positive 3?
5 and 2.
5 and 2, how?
Negative 5.
Positive 5 minus 2, that would give you x equals negative 5, and x equals positive 2. Y'all okay? All right, what about number 7? What would we do first?
Or do the exponent thing with 3.
Okay, make the 3 the exponent first. Why did I have the 3 as the exponent and not with the x minus 3? Why does it not x minus 3?
Because you can clearly tell that it goes with the wall.
X minus 3 is not in parentheses, which means they are not grouped together. They are not in parentheses, so this 3 is in the front of that log, which makes it an exponent. I really hope that we are off of our phones and paying attention to what I'm doing. I hope. That's what I see. Because there's a couple of you. So that goes to the exponent, right? So, log base 2 of 5 to the third. All right, you see anything on this side?
The exponent.
There you go. So, log base 2 of 10 to the second. Now what?
Dang, that hurts.
Huh?
Is homework done?
No.
X divided by
Very good. We're going to, subtraction means divided by. So, x divided by, what's 5 to the third?
125.
125. There you go. And then what's 10 to the second? There you go. All right. I got one log on both sides. What can I do when I have a log on both sides? There you go. And how can I solve that?
125.
And you should have gotten a pretty big number, but it's okay. Y'all okay? All right. What about number 8? What can I do first on here? The what now? Exponent. So the 3 is the exponent, and the 2 is the exponent. Okay, how do I write 5x squared? What do I have to use? Parentheses, because 5 squared is 25. Now what? Divide them.
At this time, can we have Hosa to the gym for closing?
What do you see now?
Hosa. Thank you.
Semi-equal. Oh.
I can't set them equal. I don't have a log on the side.
Yeah, see, this is where I don't remember.
Yes, you can. We just took a test on this right here. This is what we just took a test on.
So you can write it as the other thing.
What's the other thing?
Exponential maybe? Is that it?
Close. What kind of exponential do you mean?
Logarithmic.
What's my base?
2.
What's the exponent? Where'd you get the other 2 from? The other side, right here. What's it equal?
X cubed over 25.
Come on, we just took a test on this Monday. Okay, now what?
Then you multiply with 25.
Yeah, but before I do that, I can reduce something.
2 squared.
Very good. The 2 squared is 4. And what else you say?
25 squared.
No?
No, the X.
Oh, that.
There you go. These 2 will reduce to give me how much? X, and where's it go? On the top. My biggest one's on top. Now I can multiply by 25. And it's 100.
Yeah.
All right, what about, let's see, number 9. Okay, what can I do first? No.
Divide.
Divide. Oh, I got a log on both sides now. What can I do? Set them equal.
Multiply 4C. But make sure you put it in the parentheses.
Yes, you're very good. Now what?
20C minus C. Or no, let's do add 5. Yeah,
You want
8
to add the 5? Okay, so it'd be 8.
equal to 19C.
Okay. That's just going to be a crazy fraction.
I think it's 9.5.
Yeah, well, we don't do, unless it terminates, we leave it alone.
Still not. Wait.
Terminates means it stops, like the Terminator, it
Oh,
ends.
it's 8 divided
Like it's 0.5 and stops. See how that one stops? But that one goes on and on and on and on and on and on and on. That's why. This one does not terminate, so I would leave it 1/9. This one does terminate, so you could either leave it 1/2 or 0.5. Either one is okay. Oh, that's, look, y'all, half of y'all in here are bad about that, okay? So look, if you physically need to divide by 19 because y'all are getting these mixed up numerous times, okay? So there's no shame in putting a step there if you need it, okay? All right, so the last one, number 10.
At this time, can we have senior superlatives to the gym for pictures?
All right,
Senior
what can I do here?
superlatives. Thank you.
What do I do? Divide. I have 2 people in class today. I'm so happy. 2, maybe 3. Now what?
Yeah.
Mm-hmm. All right, now what?
Squared.
No.
5 squared.
5 squared is 25. Now what? Mm-hmm. Okay, let's see. That's 50x minus 25. Bless you. All right, now what? Add 25. So that gives me 28. Subtract the x. 49. Divide. And those both reduce by what? 7? So that's 4/7. Did you got it good? Y'all okay? No, we're not? Okay, here's what we're going to do. We are going to learn a new lesson today. Tomorrow we are going to review both lessons. We're going to have a checkpoint tomorrow. Grayson said you remind me to give you that checkpoint before you leave, okay? I did give it to you. Wonderful. I'm on top of things, aren't I? Yes, dear.
Can you give me that checkpoint too? Because I'm going to
Remind me, yes. Okay, also on Friday, I will give you the opportunity to do homework corrections for half credit, okay? So homework corrections for half credit, but if you turn it in late, hate it for you. So if you turned your homework in on time today, then I will let you do corrections on it on Friday, okay? Yes, sir. Yes, we're going to go over that. Okay.
We have some that you would put in.
Okay. All right. So here's what I need you to do. I need you to turn to page 3. Turn to page 3. It's really easy, but you're going to need a calculator. So please quickly make sure it is math class. You should have already had a calculator. But if you don't, go grab one real quick.
Page 3.
Yes.
And the 7.3.
7.6. It comes right after page 2 that was your homework.
It says common logarithms at the bottom.
And it's on the board.
Pretty sure.
See that? So if you don't see a base, it's understood to be a base of 10, right? Do you remember yesterday how y'all were asking if we could check our work to plug it back in? And I was like, you don't know how to do that yet? Mm-hmm. Now you're going to know how to do that today, okay? So if you look on your calculator, you see at the bottom of it, right below the x squared button, is a regular log. That's a common log, right? Which means if I plug it in, it's only going to do base 10. It won't do base 2. It won't do base 6. It won't do base 7, right? Does that make sense? All right, so here we go. So all it says to do is use your calculator. Now, we did not, I stole this from somebody else, so I didn't have to make my own. We're going to round to the thousandths, which is 3, because that's what the AP test does, okay? So we're going to get used to doing that. All right, here we go. So all you do is you just plug it in. Log 5, close your parentheses, hit enter, and what do you get?
0.698.
We'll round it to 3.
0.699.
0.699, because that 9 rounds that 8 up. Get it good? Okay. I figured we'd do an easy lesson today since yesterday was kind of complicated. All right, what'd you get on the next one? Negative what? It is negative. 0.523. Do y'all agree with the rounding? Okay, what about number 3? Log of 7. 845. Do y'all agree with the rounding? All right. And number 4?
Negative 0.301.
301? Okay. Does everybody agree with the rounding on that? What do you notice about those?
The ones that are under 1 are negative.
Yeah.
Very good. If they're less than 1, they're negative, right? Oh my goodness. Why is that? Because logarithms...
Logarithm of 10 equals 1.
Yes, that is true. But logarithms are another way to rewrite what? Exponents. And if we have a decimal is another way to write what? What is 0.5 another way to write? 1/2. A fraction, right? So remember when we did fractions, that the number on the bottom would have an exponent? Let's say it was 2, right? And when we move it up, it would become 3 to what power? Negative 2. Does that make sense why those are negative now?
Wait.
What is 0.5 another way to rewrite? 1/2, right? So I'm going to pick, I'll do 2. Okay. So 1/2, right? Let's say let's just say this is, let's start back over. Let's say this is 1/2. This exponent is understood 1, right? When you move it to the opposite position, that exponent now becomes negative, like we've been doing, right? That's why the decimals, which are another way to write fractions, have negative answers, because their exponents are negative, because logarithms are another way to rewrite exponents. Are you good now?
At this time, can we have
Sure.
Who's Who to the gym for their pictures? Who's Who. Thank you.
Okay, here we go. Let's look at number 5. Now, I don't think we're going to need to do all these, but let's just look at them. You ready? All right. So, if I needed to get rid of an exponent, let's say I need to get rid of an exponent of 2. If I need to get rid of a square, how do I do that? You square root, and what you do to one side, you do to the other side, right? Let's say I needed to get rid of dividing by 5. How do I get rid of dividing by 5? You multiply, and what you do to one side, you do to the other side, right? Does that make sense? Okay, so I need to get rid of this base of 4. And I can do whatever the heck I want to as long as I do the same thing on the other side, right? So what have we been dealing with? This whole chapter. Logarithms, Anthony, right? So I'm going to do the log of 4 to the x. And as long as I do that to the right-hand side, then they're balanced out, right? Remember in science, they got to have a balanced equation in chemistry?
Wait, so is that 4? Why wouldn't it be on the bottom?
Because it's a regular 4. You're just bringing this down. You just put the log on both sides. All right. There is a base. If you don't see a base, what's it understood to be? Base of 10. Very good. All right. Now, I know how to rewrite logarithms. What do you see that we can rewrite?
Can you make it log base 4?
No. That 4 is a regular 4. It's not a base. You can't set them equal yet. They already are equal. And if I did that, that would be the same thing I already had. Look back at your notes yesterday. Yeah. Oh, that's right. You don't. I'm sorry. Okay, well, let's talk this through, shall we? We learned about 3 properties yesterday. Remember one property? Product property.
The exponent.
What is the exponent? The power exponent.
Make it equal to 0?
No. What is the power exponent? Remember what it says?
Oh,
It
it
is
would
like
be
the one
x
you put in the
log.
front.
Very good. This x is going to go to the front. So it's going to go x log 4 and log 10. They do not have bases written. Why do they not have bases written? Because what is understood to be the base right here and right here? 10, okay? That's why they don't have anything written. Now, don't let it freak you out because they are logs. How could I get x by itself now?
You just subtract the log.
That is not adding. You would divide by log of what? Log 4. Why would I divide by log 4? Because that's the one with the x. It's the same thing we've been doing since forever. It's just got a log in there. No. Well, that isn't an exact answer, but I need an approximate answer. So, we would do log of 19 and close your parentheses. You have to close the parentheses, okay? Then we would divide log of 4, and we're going to get a decimal. What decimal did you get? 2.124. Very good. Now, can I check that? How could I check that? Plug it in for x, right? So 4 caret 2.124, and it should give you close to what number? 19. Now, why did we do it this way? Because before, remember last test, we had something like this. We had like 4 to the x equals 16, right? And what did we do then? We had to make them have the same base, right? Why could I not do that for 5? They don't have the same base. Do you see why we're doing this different now? Okay, let's look at number 6. Do they have the same base? Just because 3 goes into 15 does not mean they have the same base. 3 to some power, is that 15? No. 3 to the third is 9. Excuse me, 3 to...
Base was 10.
No, the base is 3, and the base is 15. When you have a log without a number, that's 10. Okay, here we go. So if they do not have the same base, because 3 to the second is how much? 3 to the second is how much, guys? 9. Look, you're going through and you're trying to do these problems and you're not understanding what's going on, and that's why you cannot transfer from one section to the other. Quit trying to do these problems and listen to the discussion, okay? How much is 3 to the second? 9. How much is 3 to the third? 27. That's why we're doing it this way, okay? You know how to do it when I'm giving it to you all at once, but when I give everything to you at different things, y'all don't know how to process it. So listen instead of trying to just regurgitate something on a piece of paper, okay? Does that make sense? All right. So why are we doing it this way? Because they don't have what? Same base. So I can do log 3 to the x and log 15. All right, what do you notice? Exponent, what can happen? Put it in front of the log. There you go. All right, I need to get x by itself, right? I need to figure out what that exponent was. So how do I do that? Divide, right? You maybe at least need to write this before you start plugging it in. So now you can see which one goes on top, okay? So log 15, close your parentheses, divided by log of 3. What'd you get? 465. Very good. You want to check it? Oh, I didn't. Oh, 465. I said that, didn't I? I didn't write it. Thank you. All right, check it and see if you get the same thing or close to it.
You get 15.00.
Close enough, right? All right. So here we go. You got 6 more. 6 more. Turn your desks, work with each other. See if you get the same answers, okay? And we'll see. Who wants number 7? Brinkley, you want number 7? What about number 8? Anybody got number 8 so far? They want to try it? You want to try it, Sydney? Okay. All right, let's see what we're doing. We're doing this.
I can do number 9 if you want. Just like, so that can be number
We're doing
9.
number 9? Okay.
Yeah, I just need to use the rest.
Hurry.
Is it always going to be 2 point something?
No, I'm just trying to give you small numbers to deal with is all.
If I got it, you'll hear.
Well then.
Yep.
There you go. There you go. Pen's right there. Grace, if I just write this on Sydney's, can you just copy? Let me do it. I can write it twice.
As long as you just sound like you want to go to something.
Okay, sounds good.
Hold on. At this point, 4, 8, 9, 8, can you make the 8 a 9 and 9 a 0?
No, because that would round everything else up. Just round that last number up.
Yeah, but it's a 9.
Oh, it's a 9? I thought you said it was an 8.
Miss Black, can you please send Brinkley Gary to the attendance window for a minute?
Yes, ma'am?
Thank you.
It's point 4, 8, 9.
Yes, so that 9 would round. Yes, yes.
What would it run up for?
It'd be 2.490. Or no.
All right, y'all check your answer with 7. Sydney, you got number 8, baby?
Yes.
Okay, what'd you get?
I'm sorry.
Yeah, come check. Just give me your answer. Yeah, just like so she's doing 11 or 10 or I can't remember. Sydney, there you go. Hey, Sydney, give me my eraser right there.
Miss Blackman, where's the log on this? Where's the log on this?
Same place it is in your calculator on the left-hand side.
Yeah, okay. That is not where mine is.
Okay, you'll check your answers on 7 and 8 so far. Do we need to go over 7 and 8? All right. So there's 9 and 10. Check your answers on 9 and 10.
Can you go back to 8 1?
All right. Who's got 11? Come on, Carnatia. Come on. We got to get through the bottom part. I need 11 and 12 done real quick. Here you go, Grace and Sydney. Sydney, Grace, I just went ahead and wrote it all in for you. Here you go. What, dear?
I thought you only use the weighted equal signs, and that means like from zero.
No. congruent is like a true equal sign with a one wavy on top. Two wavy signs like that is approximately. Like, this is congruent. That's congruent. This is approximate. All right, so there's 11 and 12. We need to go to the bottom part real quick, okay? Any questions? Y'all okay? It was pretty easy, right? All right, let's go to the bottom. Let's see. Brinkley, can you read that bottom bullet for us, please?
Since our calculator uses common log, the change of base formula allows for equivalent log expression that do not have base of key.
Okay, so do you see this example right here? Your base is going to be your numerator, right? You watching? Your base is your numerator. Your your base is your denominator. Your base is your denominator. So doesn't that make sense that your base should be on the bottom? Base is bottom. So what's your bottom for number 13? 3. So that means the 20 is going to go on top and the 3 is going to go on bottom, right? Now you can check the answer. So log of 20, close parentheses, divided by log of 3. What'd you get? Y'all agree with that? Okay, what about number 14? What's your base? 6 is your base, so that's going to go on bottom, and the regular number is going to go on top. So it's log of 8, close your parentheses, divided by log of 6. Scotty, you write this on your paper, dear? Okay. What'd you get? 161? Okay. Any questions? All right, what about the last one, number 15? What would you write?
Log 140 over log.
There you go. Perfect. And what did you get as an answer? 070. Perfect. Y'all okay?
Yes, ma'am.
Okay. So here's what we're going to do tomorrow. What are we going to do tomorrow? We're going to do a new ACT problems. We're almost through with this. How about we say when we finish this book that we'll do like a ACT prep test or something. Like it won't really go in the computer, but we'll just kind of see how we're doing so far. Does that sound okay? What, dear? Yeah, we got time. We can go ahead and do it. Yeah, I'll go ahead and hand them out. In about 5 minutes.
Well, that's fun. That's hard to do. I have no idea. That's fun, man. I'm kind of tripping myself. Well, I don't know how I get over it. I don't know either. I'm kind of tripping myself. What are we going to do earlier? Yes, ma'am. You were probably earlier.
We are. I'm going to go ahead and hand it to you. So if you want to go ahead and get started.
That's right.
Oh, okay. I'm sorry. All right, so Grace and Sydney, don't forget that there'll be a video for the notes that you missed, okay?